this other part. So this next part now, what we're doing after establishing buoyancy force and laying it out like this, then we can now look at some examples. And if you get now this concept, it will be very easy to solve any question on buoyancy force. So we have a question here, and I would like to ask Precious to read for us this question.
The question is, a solid weighs 237.5 grams in air and 12.5 grams in a liquid in which it is fully submerged. The density of the liquid is 900 kg per cubic meters. Calculate the density of the solid. Question 2, calculate the density of another liquid in which the same solid would float with 1/5 of its volume exposed above the liquid surface. Then data of solid of air, the mass of solid in air, 237.5 grams, 237.5 times 10 to the power negative 3 kgs. The mass of the solid when submerged in the liquid is 12.5 times 10 to the power negative 3 kgs. The density of the liquid is 900 kg per cubic meters.
Awesome. Now, this question is there in your tutorial sheet. I don't like the fact that they says a solid weighs. Now, weighing, this is supposed to be Newton. All right, not grams. So I got it like the way it is in the tutorial sheet. It could have been the, because whenever we talk about weight, we talk about Newton. All right, this is also supposed to be in Newton. All right, so anyway, let's just see how to solve it. These are just sign conventions, and let's try and pretend. Let's pretend they are masses. Let's pretend they are masses, like the way they've given us grams. I got it directly from your tutorial sheet. Again, one thing that I always say is that when you are solving a question, if you have 5 minutes to solve a question, how many minutes are you supposed to spend on thinking about what the question is talking about? How many minutes? Chipo, how many minutes?
You said 4.
So you are supposed to spend 4 minutes thinking about a question, drawing a diagram if you wish. You have to draw some diagram. It's always important to draw a diagram. Even if you don't understand anything, try and draw a diagram. Try and collect the data. You should try and do all that in the 4 minutes. Try to read the question again. Some of you have a tendency of, when you look at a question, oh, density, what not? You just start writing formulas and you even start calculating. At the end of the day, you get an answer wrong. Remember, this physics at the university is not about just putting formulas. It's about understanding exactly what the question is saying. So we have a solid, and that's how come when reading the question, make sure you read it with slowest pace ever. So Precious was reading fast. She was supposed to read very slow. Yeah. So reading slow, it's supposed to go like, you should be reading one sentence at a time. A solid weighs 237.5, it's supposed to be newtons, but I have put grams, okay, newtons, or should I say grams? It weighs that much in air. But then when you put it in the liquid, the weight reduces. What has happened? All right, in air, it's this much, but in the liquid, it is this much. So immediately when you see that an object is submerged in air, or an object in water, in air, it weighs this much, but in a liquid it weighs this much, what should come to your mind is that buoyancy force was counteracting the weight, all right? Buoyancy force was up and the weight was acting downwards. So obviously that is the reason why the weight, when we measured it, seemed to have dropped, because buoyancy force was acting, all right? It's more like there's another hand which is helping you. You try to lift something in air, it is weighing this much. But when you go in the liquid, you discover that its weight reduces because there's another set of hands helping you to lift it. And this is buoyancy. So they haven't really even mentioned the word buoyancy in the question, but what should come to your mind is that buoyancy has happened here for the weight to reduce. Now this is how much it was wholly submerged in the liquid, all right? The density of the liquid is given by this much, and here we have been told to calculate. So what are we being told to calculate? Calculate the density of the solid. We have been also told to calculate the density of another solid in which this same object would float 1/5 of its volume exposed above the liquid surface. Now that's another interesting question. Here now in this question, as you see, it's not wholly submerged like this word which they have used, but they have said 1/5 is above. So if 1/5 is above, then what is below? So for example, if this is an object, if 1/5 of this object is above, if this is 1/5 of its volume, meaning what is under here, it is 4/5, not so? 4/5 of its volume. So if you have a liquid like that, and then this liquid is cutting across like that, and then you have liquid all over there. So meaning when you be computing your volume on buoyancy force, when you be computing your volume on buoyancy force, are you going to use this 1.5 or you are going to use this 4.5 on part 2? Even before we solve part 1, let's just discuss part 2 for a short. So I've been told that 1/5 of its volume is above the surface. Then we expect 4/5 of its volume to be down. So which volume are we going to take when calculating our buoyancy force? Let's try and ask our new friend Mubanga. What do you think, which volume we are going to take when calculating our buoyancy force?
We are going to use the volume under the surface of the fluid. So that's the 4/5, the 4/5.
Awesome, awesome. So we'll be able to see properly how to calculate that. But on the first part, you see, it is wholly. When it is wholly submerged meaning we get the whole volume. The volume of the displaced fluid becomes equal to the volume of the solid. So the whole volume, will use it. So now let's see how we can use, they're telling us that calculate the density of the solid. How can we use this information to calculate the density of the solid? Now let's see how we're going to do that, given this data. So we don't know the density of the solid. We don't know the density of the solid. Again, here what we have is on question 2, they told us to find the density of another solid, another liquid. So let's ignore this part first, because this is going to come on part 2. the density of the liquid too. But as we are concentrating on this part one, which they have asked us to find the volume, not the volume, but the density of the solid. Now the solution will go like, for us to find the density of the solid, the strategy that we're going to do is we have to find the buoyancy force that a liquid exerts on the solid. All right. So buoyancy force in this case, remember, I think I told you that buoyancy force, all right, if an object is floating, I should have mentioned that as well. Now, this is only for an object which is floating. When an object is floating, that is only when summation of forces in the y-axis are equal to 0. And that is the only time we can find our buoyancy force being equal to the weight. But if an object is fully submerged, sometimes they use the word wholly. But if an object is fully submerged, what do we have? We have the buoyancy force should be equal to what we have here. If this is when an object is fully submerged, the buoyancy force will be equal to the weight of the object in air over the weight of the object in the liquid. Are we together there on how the clarifications I've made? Are we together there?
No, sir. Explain again.
No.
Okay. I think what I'm saying is that, remember here I said that if you can look at this diagram, this object that we're looking at is floating. It's not submerged fully in the fluid or in the liquid. So in this case, since it is floating, only when it is floating do we say summation of forces in the y-axis is equals to 0. All right? Only when it is what? Floating. 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 Anyway, I'm failing to write properly with my mouse. I'm not using a pen. This is my mouse. It's very hard. If you have ever tried writing with your mouse, you'll find it's very hard. So when an object is floating, what we have is that summation of forces in the y-axis is equals to 0. And we get to have a situation where the buoyancy force, all right, buoyancy force minus the weight of this solid equals 0. Meaning buoyancy force in this case is just equal to the weight of the solid. That's what we said. When an object is floating, buoyancy force is equal to the weight of the solid. But when an object is fully submerged, they even use the word wholly, like that, wholly. All right, wholly is the same as fully. If an object is fully submerged, all right, if an object is fully submerged in a liquid, then to get our buoyancy force, it will be the weight of the object in air, all right, minus the weight of the object in the liquid. Is that okay? Does that explain now how we have the buoyancy force being equal to weight of the object in air minus the weight of the object in liquid? Is that okay now?
Sorry, sir, I want to take you back.
Where now?
Huh?
Here?
Yeah, I didn't understand. I didn't understand how you computed the 4 over 5.
4 over 5.
Yes.
Here we'll come to it. We'll come to it on
How
part
did you
2.
compute?
We'll come to it on part 2. So let's first find part one.
All right.
But here, do we get it how we have said buoyancy force is equals to weight of the object in air minus the weight of the object in the liquid?
Yes.
For me, I'm not very clear on that one. How it comes.
Okay. So let me give you an illustration, all right? So in air, we don't have buoyancy force, right? So if you weigh an object like that, you put it on a weighing balance, you discover that it is 2 newtons, all right? You go and weigh it in the liquid, all right? It is now submerged in the liquid, all right? You try to weigh it, you find that in the liquid it is 1.5 newtons. All right. What I'm saying is that in the liquid now, it becomes 1.5 Newton. Why do you think we have measured this 1.5? The reason why I've measured this 1.5 is because there is buoyancy force acting on it. It is trying to oppose the weight. But it is just that the weight of the object was 2 newtons. Even in here, it is still 2 newtons. But what we are going to measure in here will be, remember we said buoyancy force is acting upward, not so? And the weight is acting downward, all right? So when we measure this, we find, when we subtract this, what we'll find is what? What we'll find is we'll find the weight of the weight of the solid in the liquid. So now what we are saying is that when we take, in fact, it will be a minus because buoyancy force will be smaller, all right? But if we get buoyancy force, if we subtract buoyancy force minus the weight of the liquid, again, one thing that I said is that an object will sink if its density is bigger than the density of the liquid. So this solid, the reason why it is sinking is because its density is bigger than the density of the liquid. So meaning the buoyancy force will be less than the weight. So when we subtract, when we do buoyancy force minus the weight of the liquid, we'll find that we'll get a negative of the weight that we'll find of the solid when we submerge it in the liquid. The weight that we'll find will be negative. So now if we take this one now to the other side, what will happen? It will give us that buoyancy force will now be equal to, this weight now become positive minus what we have here, the weight of the solid submerged in the liquid. So now this is what will happen to buoyancy. Now this one would have been 0 if the object was floating there. But since it is sinking, when we do buoyancy force minus the weight, we'll get a negative. When we measure it, we'll get a negative weight. Why is it that we are getting a negative weight? Is because buoyancy force now will be less than the weight of the liquid, and we'll have a negative weight. So if we want to find what buoyancy force is, we just get, when we take this weight, we take it to the other side, it will now be weight minus the weight of the solid in the liquid, and that is what we have written here. Are we okay there? Simbarasha?
Yes, yes, sir.
You get it now?
Yes, yes, I did.
Okay, so that is what we are having here. Is everyone clear now? Is everyone clear on how we have gone about finding the buoyancy force?
Yes.
Yes.
Awesome, awesome. So now, remember we were getting the weight, the masses in kg, So when we go on the other side, what are we going to do? We are going to multiply by 9.8. So that's how come we have seen the weight of the object in what I've gotten the mass multiplied by 9.8, mass multiplied by 9.8, like that. But sometimes you see that in some calculations, they will leave out the 9.8. But here I've not left it out because we're given it in grams. So to get the weight, we multiplied by 9.8. And that's how come we're getting the buoyancy force. Someone should have asked that, why are we solving for the buoyancy force? Where in the question we have not even been told to find the buoyancy force. We have been told to find the density of the solid. Well, one thing that you would realize when you are solving is that sometimes you have to solve some questions sometimes it will be 2-part, 3-part, or 4-part. You solve for a certain thing, which will help you to solve for another thing, which will help you to solve for another thing, until you get to the point where you really want. So now, the reason why we got the buoyancy force is because we know that buoyancy force, all right, this buoyancy force, we can also relate it to the volume of the displaced fluid, all right, times the density of the displaced of the liquid, multiplied by acceleration due to gravity. All right, we could have also expressed it like that. Buoyancy force is the volume of the displaced fluid multiplied by the density of the liquid. And in this case, did you know that in this case now, since we are talking about wholly submerged, meaning the volume of this displaced fluid will equal to the volume of the solid, since the whole of the solid is in the liquid, meaning the volume of the displaced fluid will equal to the volume of the solid. So instead of writing volume of the displaced fluid, we can write volume of the solid multiplied by the density of the liquid multiplied by acceleration due to gravity. Have you seen now what we have? We could have also used this way to compute the what? We could have used this way to compute the buoyancy force. And we are saying buoyancy force is equals to, even here, we would have used the, instead of us writing 9.8 multiplied by the weight and all that, we would have used the volume of the solid multiplied by the density of the solid multiplied by 9.8, all right? And then would have subtracted this value here, all right? This value here, all right? Now, remember we are looking for the density of the what? Of the solid. It will now be easy for us to find the density of this solid, as you will see in the next part of our calculations. And then you will see now how it was necessary for us to find the buoyancy force, because it was going to help us to find, when we do the expressions, it was going to help us find the density of the solid, because that's what the question is asking. The question is saying, find the density of the solid. So now how do we find the density of the solid? All right. So we know that we can as well find the volume. All right. From there, we can find the volume of the displaced liquid. All right. So now the way we solve physics is just that it's like a puzzle. You have this part, you can use this part to get another part, just like that. Sometimes you may use a shortcut, sometimes you may use a long cut, but at the end of the day, you should get to the final answer. There's no one way of going about these things. All right. Is that okay? Friends, are we together? Are we still together even up to this point?
Yes.
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 Mm-hmm. So why are we finding the volume of the solid? Is because when we go back to this formula, which I'm telling you, is that in the question, we are not given the volume of the solid. So if we can find the volume of this solid, then these unknowns will have figured them out. The only thing that we will not know is the density of the solid. If we know we have been given the density of the liquid, we know 9.8. If we can find the volume of the solid, meaning we can factor out this part. The only part now will be just finding the density of the liquid. All right. So we can express, like I said, we can express buoyancy force in terms of volume times density times gravity. Volume of the solid. Yes.
I think me, I'm lost. See, here, where we found the buoyancy force. Now here again, you have found the specific weight, which is 8.82 times 10 to the power 6. Why are we finding the specific weight?
Where are you saying? Where are you saying?
Here, the specific weight after finding the buoyancy force.
Here, here?
No, that down. That's the last part.
Here? Or you mean here?
Yes.
Now we are still talking. I've not yet come to explain why we have found the specific weight here. All right. The specific weight meaning we just removed the volume part. All right. If we want, we can factor out the volume and the, remember, weight, specific weight, it just means we have removed the volume. So we are still chatting, and we'll see why we have removed the volume. All right. So now, all right, from here we can calculate the volume of the fluid displaced, and it's, like I said, it's equal to the volume of the fluid. I mean, the volume of the displaced liquid. Volume of the displaced liquid is equal to the volume of the solid. All right, but instead, all right, since we have the buoyancy force as that, all right, but instead of mass, we have buoyancy force, and instead of density, we can have the specific gravity. All right. And why have we found the specific gravity? As you said, we wanted to find the specific gravity so that we can use it to find the volume. Remember, specific gravity means we have removed the volume. Remember, if we cross multiply here, all right, you know that specific weight, right? If we multiply it by the volume, we'll get the what? We'll get force, not so? Chipo, are you there?
Yes. Yes.
So you see the reason why we didn't multiply by the volume here, because first of all, we don't have the volume, and so it will only be necessary sometimes when you don't have something is you can find a specific weight. You already know that in the specific weight I've left out volume, but I can find volume knowing that I have the buoyancy force. The reason why we wanted to have the buoyancy force is because we know that, like I always mention, buoyancy force is equals to the volume of the solid in the liquid, all right, the volume multiplied by the density of the liquid, all right, this is L, and then multiplied by 9.8, all right? So since specific gravity is just this part is specific weight actually, all right? We can make V the subject of the formula and find V to be equal to specific weight, or I mean, V equal to buoyancy force over specific weight. Are we following, friends?
Yes,
Yes.
sir, kind of.
Kind of.
Yes.
Yeah, sir.
kind of.
I think I'm lost, like completely. Okay, partially lost. Here, on the specific weight. Which mass did you use to find the specific weight? Since weight is equal to mass times gravity. Yes.
Okay, so I don't know if I can take you back here. What did we say about specific weight? Specific weight is just density times what?
Density times gravity. Okay.
You get it?
All right.
All right.
Yes.
If we want to get weight, if we just want to get weight, then we multiply volume to the specific weight. All right. We multiply the volume and the density like that. So if we have the weight, all right, if we have the weight, we are saying weight is equals to the volume times the gravity, the density, and acceleration due to gravity, all right? And then here now what we have said is that we can find, since we know the density of the liquid to be like that, we can use it to find the specific weight. We have used it to find a specific weight because we know we don't have the volume yet. We don't have the volume, but we can find it. We can find the volume by dividing this buoyancy force over specific weight. Is that okay?
Yes.
Yes.
So now, why are we finding the volume? Like I said again, physics, sometimes we solve it in parts. I'm trying to repeat these things so that you guys get the concept in your head, because I've seen the quiz which I gave you, it seems you guys didn't get the concept in your head. So I want to make sure you get the concept, and if no matter how many times I need to repeat it, you have to make sure you get the concept to be successful in physics. So again, because we are just remaining with a short part, what will happen is this meeting again will expire. Then for 15 minutes again, we'll come back. Yes. Mr. Wisdom.
Hello?
Yes, Mr. Wisdom.
Yes, sir. I have a question, sir.
Yes.
Is buoyancy force same as the mass?
Buoyancy force same as mass.
Are they the same?